Good evening. I'm Milton Curry, Dean of the USC School of Architecture and the Della and Harry McDonald Dean's Chair in Architecture. And it's great to welcome all of you to our Spring 2022 Public Event Series, Architecture Engaged. And I want to thank Public Events Committee Chair Alvin Huang and Keiko McNally, our Head of Communications and Events, for helping us organize this event this evening. There will be a Q&A immediately following our lecturer's remarks, curated and moderated by Doris Sung, Head of Undergraduate Programs here at USC Architecture. Please place your questions in the Q&A function, and we'll be sure to include all of those in the discussion. Mollie Claypool is Associate Professor at the Bartlett School of Architecture, Faculty of the Built Environment, a position that she has held since 2014. She teaches the history and theory of digital design, computation, and automation. Her teaching utilizes political, feminist, and activist theories and knowledge to shed light on design and spatial issues, drawing from her experience as both an activist and a design practitioner, which is really great and unique. She's currently co-leading with Fiona Zisch, Harriet Harris, and Phoenix Perry the development of a very interesting international network of architecture, arts, and cultural organizations entitled Collaborative Futures for the development of a hybrid virtual platform for collaborating on cross-disciplinary architectural research and education that puts at its center concerns around care, consent, equity, and inclusion. She's also managing editor of Perspectives Journal. Since 2018, she's been doing this, where she has spearheaded the launch of innovative open access online journal information and articles and scholarship and research dedicated to the promotion of innovative historical, theoretical, and design research on computation, automation, and architectural design and fabrication. She's also director of the Automated Architecture Lab at the Bartlett, and her research is really concerned with cultural consequences of increasing automation in architectural production. This has led to public lectures and convenings, over 50. It's led to co-authored books. In 2019, she co-authored the book Robotic Building, Architecture in the Age of Automation. And what else? She studied at Pratt Institute and the AUAR School of Architecture, and is currently a fully funded PhD candidate as well. And in addition to her work in architecture, she also works as a birth activist, doula, and trade unionist. So all great qualities and completely in sync with being an innovative architect and architectural innovator and teacher. And I really look forward to hearing her and her perspectives on design and architecture this evening. So please join me in welcoming Mollie Claypool virtually to USC Architecture.
Thanks so much, Milton. So can everybody just see the presentation? I hope so.
Yes, we can see it.
Okay, great, thanks. The endless question. Thanks so much for having me to USC virtually. I very much appreciate it. And thanks for the generous introduction, Milton. So I'm really looking forward to sharing with you some of my thoughts on automation and architecture. And this talk is kind of titled New Forms of Automation for Architecture, which hopefully you'll see what I mean as we go through it. So to start, I'd like to note that throughout my talk today, I'm going to be referring to collective nouns and pronouns, the team or we or our. Sometimes I'll be referring to the team within Automated Architecture Labs, which we have shortened to AUAR and we pronounce as our. But sometimes I'll also use the word our to describe a group of people that are making decisions together. So the projects that I'm going to show are not large projects in terms of scale or budget, but have often had really large teams embedded in the processes of decision making. On the projects that I'll show from the last 2 years of work, there were a few hundred people working together. And these people are not primarily those with built environment expertise. They're not architects, they're not engineers, they're not technologists. They're the people who live and work in the communities that the work we're doing is taking place in. And this is really a key part of the strategy for the way that we think about automation. It's informed by practices used in activism for consensus-based decision-making, as well as dynamic rank structures, where leadership changes throughout the course of any one action. So we're really interested in how automation can provide an opportunity to better architectural production practices, to make those practices more accountable and better aligned to more equitable and inclusive value systems. So this engagement of a wider network of stakeholders is really important for us. So consensus-based decision-making enables power to be shared, with decisions being made by the people who are fundamentally affected by those decisions. And this allows us to protect the interests of the minority in any group, because everyone has to agree on any one decision. And this requires really active listening. And we're also interested in dynamic rank structures, which can be used alongside consensus-based decision-making, but is not mutually exclusive to it, that also shares power using non-permanent hierarchy. And this can be used to privilege certain specialist knowledge when that knowledge is required for decision-making. And it can also be used when the consensus model is insufficient. So in our work, we think about the ways in which we can dismantle the power structures that have contributed to what we know as the status quo in the built environment and built environment production, where existing methods of production and the policies that frame and reproduce these methods are not really geared to address major global issues. Now, in the UK, we have a huge scarcity, not just of companies that are able to produce and deliver housing to meet the kinds of needs that we have here. We have 2 billion homes needed over the next 80 years, but we also have a scarcity of land, where we have half of England being owned by less than 1% of its population. Now, this has created a scenario where I am in the UK, over 8.4 million people, or to give you an idea of what this means, this is 1 in 7 people are affected by the housing crisis. And these are numbers represented on the screen in terms of different kinds of housing precarity, for example, homelessness or overcrowding or rent arrears, etc. And existing methods of architectural production are really not geared to this issue. They're also not geared to issues like the climate emergency. For example, if the cement industry were a country, it would be the 3rd largest emitter in the world. And just like architecture and construction, planning is also not generally well suited to deliver on these kinds of needs. Now, in many places like the UK, planning practices are often heavily top-down, and they engage in the kind of processes that treat community consultation as though it's an afterthought. And this produces a lack of trust in planning processes and a culture of NIMBYism, or not in my backyard, within those communities themselves. And this further widens the divide between housing developers and the local communities that they're building for. And as we have seen, in the last few years, and also very recently, architecture as a profession has become more and more fragile, with very insufficient disciplinary practices based on competition, undervaluing, and bidding culture. But I'd like to argue that these practices are practices are designed, they're historically constructed, and to provide some hope, because insofar as these practices are designed and constructed, they can be redesigned and they can be reconstructed. So one of the ways that I've entered this reconstruction is through the term folk politics, which I find very useful for beginning to understand the impact of these kinds of disconnects that we see within built environment production. Folk politics are what sociologists Nick Cernick and Alex Williams have referred to as, quote, tactics and strategies, which were previously capable of transforming collective power into emancipatory gains, but are now so divorced from actual mechanisms of power that they're incapable of transforming capitalism and therefore have become drained of their effectiveness. Folk politics, for example, one of the biggest examples that they use is the Occupy movement. These are politics that emphasize temporary, spatial, and conceptual immediacy. Now, folk politics in my kind of area of work in terms of digital design and fabrication, I would argue has settled into a kind of digital neo-formalism, where you privilege the symbolic, the iconic, the aesthetic, and the representational, where you emphasize subjective experience or effect, rather than paying attention to the impact of our decision-making on the vast majority of people around the world, or even actively and collectively acknowledging the consequences of this very obvious disconnect between design practices and building cultures, where one really doesn't speak to another. Now, I'm very hopeful. I think this conversation at the moment is really changing, and I'm really pleased to see that that's happening. Now, it's important to note that automation really works in the opposite direction of folk politics. It works at moving our attention out and up from the local, rather than pulling our attention down and into the local. And we're really in danger of folk politics playing out in new arenas globally when it comes to one of the biggest opportunities that we can see in built environment production to begin to address issues like the housing crisis or begin to provide alternative solutions. And for me, that's automation. Now, for decades, the dominant narrative around automation in construction, for example, has been around the loss of jobs using manual labor. Now, often the technologies that are developed to replace these jobs focus purely on productivity gained by implementing, for example, the use of a single task robot, in this case, the bricklaying robot, but you also see tile laying robots, welding robots, et cetera, are obviously very common. And other benefits, such as improved worker health, are really treated as a peripheral positive outcome rather than being explicitly embedded in the conversation around this technology's development. And it's also really important to note that these kinds of technologies are products that are really only available for those with extreme wealth to begin with. When it was launched in 2015, Sam, the bricklaying robot by Construction Robotics, cost $500,000 US, and it currently costs £16,000 a month to rent in the UK. And yet these robots are extremely limited. We actually see them now on secondhand markets in the UK, because while they're technical innovations in digital fabrication or in digital construction, they're solving very narrow and very localized problems within the industry itself. So let's zoom out as well. If we take a similar approach to automation as automobile manufacturing, we see modular housing factories such as Katera or Katera's old factory, or Legal in General in the UK, really resulting in the centralization of housing production to off-site factories. And this really disconnects this production from the context in which these systems are deployed. And the workers that build the housing systems produced in mega factories are currently imported onto building sites from elsewhere. And this results, what we've seen this resulting in is the marginalization of local employment and economic development opportunities. And factory-made housing is then seen by those local communities as displacing local jobs. And this in turn creates resistance and skepticism amongst local communities and begins to create really limited localized capacity for housing produced using automation. And it's also really not marginally different from other examples in history. This is Levittown's building kit, for example. And the failure of this model is currently incredibly acute. We saw Katera collapsing last year and filing for bankruptcy after misstating financial reporting around projected performance and employing senior leaders that lacked knowledge of the construction industry. Legal in General in the UK, alongside Katera, are great examples of how the automation gap in construction, where construction is one of the least automated industries in the world, is not just a problem that can be solved by a single technology or a vertically integrated production chain. It is not just a problem of efficiency or a problem of productivity. It's a problem of design. And design, for example, touches on frameworks for labor, it touches on frameworks for interdependence, it touches on resilience, on policies, and on structures for decision-making and care. So we started to work on these ideas in this book published in 2019, where we constructed a narrative around automation through 5 themes and 15 projects. The themes were craft, print, assembly, many, and diffuse. And we began to identify the impact that automation has and will have for processes of production in the built environment, while also extending our argument towards new understandings of how relationships between architecture and social practices might begin to be transformed by automation. So instead of thinking purely at the scale of the machine or the tool, or at the scale of the place in which that production takes place, we think about the consequences of automation. And that primarily led us to the questions of who owns what, why, and how. So while we know that digital architecture tries to play innocent, automation is not innocent. It automatically forces positions. It forces us to question what a fully automated society would mean. Would we all need universal basic income? Who owns the robots? Which jobs remain? Will we all live in housing created by big tech? These are questions and deep cultural issues within architectural production and society that highlight the incapacity of current practices to adapt to automation. Yet when we use this term, when we use the term automation, we're suddenly able or even forced to really think about labor, to really think about jobs being lost in new kinds of rust belts, about control and about ownership. And then we're not forced to see automation as an embodiment of folk politics, but we're forced to see it as a design project. And then we have to ask if this is the model for architecture that's widely failing in the face of automation, or even what we may recognize as a kit of parts system still has thousands of bespoke parts that need to be made and produced in processes that are suitable to other industries. So then we ask, what is an architecture that is designed for automation? And this has become the backbone of much of our work in the research lab and also in our spinout company, AUAR Ltd, for the last 3 years. Oops. So what we've proposed is that we must radically redesign how architectural parts are designed in relationship to automation in 2 ways. The first is both as a process, so in relationship to what technologies that we use, but also as a framework for production. So in relationship to the context that we're working and how accessible is the benefits of automation for the people that we work with and the people that we serve. So what's this resulted in is a proposition that a significant reduction in the number of architectural parts is possible. And it enables a rethink around this dichotomy that exists between design and building cultures. So what if we just had one architectural part instead of thousands? Now this approach, the Discrete, familiar to those at USC, treats architectural parts as code. Parts are not being constrained to types like column or floor slab or beam or staircase. So a slab is not just a slab. And importantly, the discrete parts enable us to really think about issues of reversibility and difference in orientation. And what we see this enabling in our work, this is some work with our students from about 3 or 4 years ago, we see this enabling an architecture that's entirely digital. Now, discrete architecture is architecture perfectly made for automation. It speaks to automation's best qualities for architectural production because robots capable of building work best when they do the same or extremely similar tasks over and over and over. The seriality and the repetition of working with one discrete part is thereby mirrored in the robotic behavior, in this case, in its assembly behavior. Excuse me. So in our research lab, we've explored collaborative robotic approaches as well, where we can begin to understand the potential line between robot worker and human worker. And this helps us co-create, co-design, and anticipate increasing automation and the impact that it might have on how people interact with automation within the communities that are able to access it. And we've also developed modular robots that operate semi-autonomously as a form of collective intelligence. In this case, the pizza bot. The question that started this was, can a building robot be the size of a pizza box? And it's a modular distributed robot with the exact same geometry and scale as the building part itself. And it's capable of moving on its own without any external locomotion. When we deploy this at the building scale, we begin to see the modular robot blurring the boundaries between what is building and what is automation. And this enables the robot to almost entirely merge with and negotiate this kind of configuration and reconfiguration of the building. This allows us to speculate on what's possible to change and adapt over the span of, for example, a day. Active robots move more passive building blocks, configuring and reconfiguring living spaces. And then if we start even earlier in the assembly process, we have begun to develop automation at the scale of the architectural element, our part itself, really trying to understand at what point is in production, if we go from the very beginning of the production process to the very end, at what point is automation its most useful? And we're seeing that it's oftentimes at this scale, similar to the scale that's used in the automobile industry. But what we also argue is that we very much need to be thinking, as we do this, that we need to preserve the way that people interact with this process in really intuitive and simple ways. So the architectural part for us needs to be designed with this interaction with people in mind. So part of the intelligence embedded in discrete architectural parts that we use is a strategy to empower communities to participate in design and making, particularly as you'll see in the design and production of their own homes. So let's talk for a minute about our building system that we've used in AUAR Labs. This is block type A. Block type A takes from modular mass production of the last 70 years, where the same part can be industrial produced, repeatedly cut out of sheet material, and reducing a significant amount of waste in comparison with other customized or bespoke cut parts. And it can also be manufactured almost anywhere in this kind of just-in-time model for production. In block type A, one sheet of 4x8 timber sheet material equates to one discrete building block. Block type A is a prefabricated post-tension system, although we've moved on from this exact system now. But this version had incorporated post-tensioned reversible connections that allow for the reconfiguration and the adaptation of the building system assemblies over time, so we can adapt the building system to various changes. Now, this is based on principles from digital materials, which is a concept drawn from mechanical engineering that has behind it principles of part variation and part reversibility. So this really enables the versatility of the architectural parts. And this is just a suggestion of some of the possible ways that block type A can be combined together. And the blocks production can be, for example, highly automated, like you saw earlier with the two robots assembling one block. We've actually got it down to one assembling one block in 15 seconds, but it can also be done manually. So block production can use readily available off-the-shelf tools that require very little expertise and training to both prefab them and to assemble. At our height of building blocks in 2020, we got one block done in 7 minutes from sheet to fully assembled. Oops. Now, the simplicity of block type A also allows us to introduce ideas around automation using mini versions of the blocks. This has become for us a toy for engagement with people who have an interest in housing or technology, but who have never been able to really get close to these ideas before or close to automation before. And we use this as a backbone for the workshops that we run within communities. This is an example from just before COVID in 2020 at a community-run, community-owned manufacturing hub in the southwest of England where I live. Very recently, we have displayed this idea for an exhibition called Shaping Space, which was the Victoria and Albert Museum at the Building Centre in London, where designs by the public were automatically captured by a tag and tracking system into a very simple combinatorial design app that we've developed. And this enabled the general public to play with the building systems and design tools that we've been working with in really straightforward and tangible ways. Now, if we zoom out a little bit from the architectural part and move towards this kind of framework for automated production, the work that we do sees the status quo of automation largely for what it is: centralized, extractive. And so what we're interested in thinking about is notions of collectivity and thinking about what's a non-extractive version of automation. So we're interested in models where workers have ownership both over the methods and modes of production, as well as the things that they produce. And a key part of this is trying to design frameworks for automation that distribute expertise and really keeps the value that is co-created by the communities within those communities themselves. Now, one of the ways that we've been doing this in the lab is by working across the UK to develop partnerships with organizations that are really active at the local community scale, building networks across the UK. So currently this is primarily across the Southwest, London, the Southwest, and the Midlands. Now in the spinout company, this is expanded to include parts of Europe that are easily accessible by transport from the UK. So for example, the Belgium and the Netherlands. And these are just some of our partners over the last 3 or 4 years. Now, the organizations that we're working with fit a kind of very clear brief in terms of being primarily citizen-led or community-led, and they're housing and arts-led organizations, and they put at the core of their work and ethics of care around doing the work. So this recognizes that both enabling participation and participating in built environment production is extremely difficult for many people and many organizations. And so we must really embed in how we work principles of care and support at the very core of the projects that we do with communities. Excuse me. Just kind of sip of water. So in the projects, we are working towards developing a cooperative model where the communities that we work with also become stakeholders in the platform. And this is very much inspired by historical and current models for cooperative networks of practices, but as well as other models like community stakeholding. Now, our funding has largely come from the public sector, Innovate UK, the EPSRC Impact Acceleration Fund, Research England, Transforming Construction Network Plus, and we've had some private funding from Epic Games, as well as a partnership with ABB Robotics, which is primarily our automation partner, our primary automation partner for the spinout company. Now, both in the lab and in the spinout company, one of the ways that we are embedding this ethics of care is designing what's referred to as a mission lock. This mission lock supports who we can and cannot work with, and really kind of keeps the boundaries of how we engage with other people, other practices, companies, and communities. Now, at its backbone, it advocates for horizontal, participatory, and equal social practices in architectural and technology, where individual autonomy and freedom supported in a structure of care lead to more creative, inspired, and empowered people in more just built environments. So, for example, the consensus-based decision-making model, as well as the dynamic rank structures, play a role in this mission lock and play a role in how we develop practices with our collaborators. Now, what we found is that this mission lock really makes the process of design production for us. It enables us to make it much more accessible for people that are typically othered by professional practice and industry, and really widens the boundaries of who can participate in the work. And a core question that we really ask ourselves is, what is the capacity of an engaged scholarship or values-centered approach to enhancing citizen-led design using automation and new housing and construction systems? Now, engaged scholarship is the equalizing of power relations, democratic practices, situation-based action, mutual learning, tools and techniques, and alternative visions about technology. Now, oh, that's annoying. this video doesn't exist. Great. Imagine an image of a design application. So I'm just going to talk about that for a sec. So we have developed a web-based combinatorial design app that was developed in 3 weeks just before, as COVID hit in 2020. And it's a web-based interface. Hopefully you'll see an image of it later. Somebody's moved things around in my Google Drive, which is really annoying. And it can enable us to very quickly develop projects with block type A. And as it's web-based, it doesn't require any specialist technology, just internet access. Oh, here we go. Here it is. So we use the Combinatorial Design App both as a training tool, and it's a leveling up platform for us between everyone in the communities that we're working in and involved in the project. And now we're using it with other people that we're working with to give us a tool to communicate design decisions in real time, really quickly in a highly accessible way. So for those we work with who don't have access to technology, one of the things that we've done is provided the tech needed for them to be able to utilize the application, as well as a home kit of mini blocks that allow them to both play digitally and physically with the building system itself. Oh, another one that doesn't exist. Great. So somebody's literally organized my Google Drive like in the last 2 days. So this is something about an AR app, but we're not going to talk about that because I can't show it to you. So recently we've been working primarily in over 2020 and 2021. We worked in 2 communities primarily. One is in Mill West in Bristol. Bristol is a city of 450,000 in the southwest of the UK, about 2 hours from London. That's where I am now. But also in Hackney in East London, but particularly around the Olympic Park. Now we believe that it's really important to work both with residents and policymakers in these communities. And the reason why is because local residents and local governments are really disadvantaged by the current way that built production is done. So in that there's a huge lack of trust from communities on the one hand with those local governments, and there's an inability to take risk on behalf of the local governments on the other hand. So Mill West in particular is a really classic example of how this has played out. Mill West is a 1930s council estate. It is built on garden city principles, has a radial arrangement. You can see it here in the top. Excuse me. And right now it's really on the edge of Bristol. It's this kind of edge line between the city and the rural, which in the UK, if you've been here, you'll know is a very abrupt edge in most places. And because of the way that Mill West was absorbed by Bristol as it began to expand, there's really no center to Mill West. It's also a place where 10 main families who have lived there since it was first built take up the vast majority of the population. So on the one hand, you have this very rich and deep multi-generational community, but it is a community that's essentially stuck in this kind of peripheral edge condition. And the architecture of Mill West really represents this. Almost every home is a 3-bedroom home designed and built for the nuclear family of mom, dad, and 2 kids. Were very rigid views about how one should live, and this is still at play today, and very rigid views about how homes should be maintained. And we've seen this play out in, for example, Dawn's life. This is Dawn, and Dawn's story really illustrates the problems that we have in places like Mill West with more traditional housing models. So Dawn is 77 years old. He's lived in Mill West his whole life. He was a civil engineer working for Boeing, which is based out in the Bristol area, and for the Ministry of Defense, which is also based out in Bristol. And 40 of his years, he lived with his severely disabled sister, acting both as her carer and as her advocate. And because of his sister's needs, he really slowly and painfully and expensively over time adapted his home from what's called a Mill West classic, which is the upper right image, to one where him and his sister could live together, but with some independence and some space for carers to stay overnight so he could get respite. But when his sister passed on 5 years ago, Don had no way to unpick his home and turn it into something that suits his needs now. And as a result, it was declared unsellable. So Don is completely stuck. So this really results in, this kind of model really results in designs that are not agile or open-ended enough to deal with change, either through the course of one person's life, like Don, or multiple generations. So we begin to we believe that by highlighting and radically rethinking the production processes that make these kinds of rather horrible housing, we can begin to really unpick why people's homes are so inadequate for their needs. So we really need to embed at the core of our work this ethics of care that doesn't get into this kind of context where you have housing that's very inaccessible. And instead, we need to create a kind of resistance to this condition. So our ethics of care utilizes a handful of different things. One of the first things is an organizational ethnographic approach to research. This is a mode of inquiry that focuses both on established and formalized cultures, but also on informal subcultures that act as settings within which social relationships between people and actors move towards a particular goal. It also proposes that we embed work on automation and architecture within the very rich history of participation in cooperative design and architectural and technology. And this expands the history of automation and architecture to other histories within automation that have really been brushed over by neoliberal mentalities. And third, we take what's called an asset-based approach. Excuse me. Now, at the core of an asset-based approach is not asking the question, what needs to be fixed in one place or one context? Instead, it asks, what's already here and what's missing, or what needs to be brought to the surface. And one of the things that was brought to the surface in one of the workshops that we ran with one of our collaborators is that this lovely man's horse was living in his kitchen. And so he needed a place for his horse, basically. But this is the kind of surprising thing that comes up when you're working with communities and asking and not asking, how can we fix you? It's more like, what is here and how can we highlight it? How can we celebrate it? Now, in order to begin to ask these kinds of questions, we have to build trust in a system that has completely broken down. So at the very core, we need to decolonize automation and put central in our work an activism that really thinks about authenticity, about active listening, and about radical inclusivity as the backbone to our understandings of space and place. And so through interlinking this together with an emergent strategy, these consequences the consequences of how these things come together can be more broadly understood as sociopolitical imaginaries. I really love this quote from Adrienne Marie Brown, where the final sentence, really thinking about the quality of connections between the nodes. So a vision of automation as a design project can be one that doesn't monopolize or centralize automation, but demonstrates the capacity for automation to accelerate the production of distributed abundance and really begin to amplify interdependence. So a vision for automation in architecture must confront the value systems and hierarchies embedded in both architectural social practices, spatial practices by radically rethinking architectural parts. But it also must redefine automation's capacity to enable increasing access to architectural production. And it also must consider automation transcalar and distributed. So while our work sometimes might look like a very localized project, if we zoom in really closely to places like Mill West and Hackney, this is also a large-scale project. We believe that by embedding and distributing automation in localized settings, we can design and deploy a much larger coordinated network that can operate using these systems between these communities, but also between almost any community, as long as an ethics of care and a mission lock remains really at the core of the work. So in both contexts, I'm just going to show you Mill West and Hackney, we set up a factory. Not in your typical factory setting. In Bristol, this was set up in a community arts organization's main studio that's usually used for youth groups and other community activities. And in Hackney, we set up a workshop in a local college for 16 to 18-year-olds where they teach bricklaying. And over the time that we were there, we offered work experience, which is a requirement for all the students to complete their studies, but it was really bringing the work experience within their institution. This is a community where a low-income population are studying oftentimes these on these courses, and there's a high level of gang involvement. So really by bringing the work experience within school for them, it made it much easier for them to access. This also meant that they were then trained to work with us as crew, so they could come out of their school and begin to work on our building sites with us. And now we have a crew of students, 18 and 19-year-olds that can be employed on projects, which is really exciting, and really expands, again, this idea of who are the stakeholders in this kind of work. Now, we use some of the apps that the app that I showed you earlier to co-design this project. This is Block West. It was a community housing prototype that has been partially reconfigured in Bristol outside Knoll West Media Center. This was the result of a 6-month-long workshop series. Block West was built out of 145 blocks. It was assembled together in less than 2 weeks. And the project provided 25 part-time jobs in the local communities throughout the 6 months of the project. For us, it wasn't really just a pavilion. It's a housing prototype where we experimented with new ways of living and working. It also acted as a training program similar to what we did in Hackney for more permanent roles being created in the community for the We Can Make Homes project, which is citizen-led housing that we've been involved with. In Block West, our group of 25 was also 50% women, and we had people aged 12 to 76. John Bennett, who was one of the local residents who worked on Block West and has also continued to work for us, was quoted saying, "The community has been at the heart. I never felt any top-down pressure. For me, it was about my personal development. I felt like I had a web of support around me with no barriers and no boundaries. I could dream it, I could say it, I could make it. It was really empowering. And for once in my life, I wasn't being told, no, you can't do that. Instead, everything was doable." Now, this is really important in an area like Knoll West, where there's no center or community hub, and where there's been historically very little investment. It's often a place where money washes through rather than adding sustainable value or social infrastructure. And so through our continuing work in Knoll West, we aim to provide a social infrastructure that can become the community hub that's missing from this area. And throughout Block West, we co-tested both the use of the combinatorial and AUAR apps with the community members we're working with, allowing us to very slowly and incrementally automate workflows and construction processes while preserving the kinds of knowledge and labor within the communities that may be using them or be affected by their increasing use. Now, as part of the project that we have been working on, funded by Innovate UK, called Can Fab, we are also developing a digital platform for multiple modular building systems, such as Mass Bespoke, U-Build, and Block Build, to be produced alongside Block Type A. Collectively, we imagine that this digital platform can be deployed in using a cooperative stakeholding model where multiple practices are coming together to serve a community's needs. We're actually doing this now as a kind of follow-on from the Innovate UK project, which took place throughout most of 2020 and beginning of 2021. So part of this project, we envisioned and co-developed a design for a housing factory that then changes over time into housing as the housing gets built up around it. And this was designed using a larger block, and this would begin to really extend the existing fabrication and manufacturing capacity within Knoll West. This was also a VR tool that we developed, begin to help training for using industrial robotics in these communities. So in this video, we're seeing some of the earlier work by the tradespeople that we worked with that they developed being robotically assembled. And this is a really useful tool for us for supporting people getting, actually the fear that comes with robots, kind of dissipating that. Now in House Block in Hackney, this was a project that we did exactly a year ago, which is bonkers. We worked, again, this is the bricklaying workshop. We worked with New City College, their construction program. We set up shop in their bricklaying workshop, and we developed the project with other local partners such as Dance Studio Wayne McGregor, East London Dance, the Building Center, and Waltham Forest, which is the local council. They have a Future Creatives program. Future Creatives is a work experience program that we've been working with, providing young people who are interested in careers in architecture and design to curate their own public programs in response to some of the questions that we ask around automation. Now, House Block was built out of 270 block type A's, shown here stacked up. We were forced to store them for 6 months. COVID really put a hole in our plans. So we had to store them in the bricklaying workshop while the world was shut down. This project was started actually in 2019 and was a kind of slow burner for us. It was in partnership with Hackney Council, which is the local government in London, and it started as a conversation around how Hackney Council could use smaller bits of land that they own and how could they activate those bits of land, but also do that by engaging local communities in network building for really beginning to rethink how we build housing. House block, I'm going to show you some final images of it in a minute, but this is animation of how we built it. There was a core part to house block. And then that core structure had next to it and around it a set of blocks that were then used to design a series of public program takeovers by our community partners. And therefore, our community partners began to adapt the structure over the course of our occupation of the site by a crew of local workers who had been part of the project for a year and a half. We provided space for sounds installations, dance pieces, meals, barbecues, filming, etc. There was one takeover. This is one takeover where a speculative living room was constructed at the front of House Block and used as a platform for performances and talks. And during the sessions to build each takeover, we provided paid opportunities for local people to get involved with the project, to begin to try and enable as much as possible the participation of as a diverse group of people as possible. This site, I wish I had a picture of the wider site. I don't think I do. It's a really interesting site. It's on the site of an old playground. To the left, there's an old school, which is occupied by guardians, which in the UK is people who pay a very discounted rent to stay in, essentially to protect buildings that are going to be developed at some point in the future, but oftentimes they can live there for 5 to 10 years. It also has some 1960s housing blocks just behind it and Victorian terraces just to the right. So it's a really diverse typological area of London, and it kind of slopes down to the River Lee. In the small builds, we reached over 100 people in the local area, with many more involved in the public program takeovers themselves. And this was, for us, a journey that brought us together with not just the council, but local community members to begin to discuss what home means to us and how automation can be used to provide an alternative solution to the housing crisis and to how we might begin to utilize these plots of land. The prototype also begins to demonstrate for us what could be achieved if we were to think about participatory approaches to housing, where local communities make use of digital modes of production, particularly in the spaces that local councils have available that are deemed too risky for development, or if the council can't really do anything meaningful with. And so we were able to show that this kind of meanwhile use of a site brings on board communities which are otherwise really perceived to be disparate and disconnected. This is a animation of house block, also transforming into a house, then transforming into housing. Also the takeovers. Oops. So I'm going to talk next about our block studios. This is work from the spinout hour. The block studios is really inspired as a project at large, is really inspired by a local Mill resident, Lucy, who's 24. When we were asked her to reflect on how able she felt to participate in discourse around these kinds of building systems, she replied, hell no to hell yes. So as part of Block Studios, we have been working with women in the community in Bristol who all bring similar stories of structural disadvantage, which has been revealed through our prior work with them, but also aspiration for change within their own lives, within their community, and within for their local community. So Block Studio tries to build on the work of Block West and House Block, and primarily builds on the frameworks for labor and production within the lab. So Block Studios has what's called a mode of public participation with AUAR as a company, but also with AUAR as a research lab. So the objectives of the studios are to seed a pilot public participation program within AUAR Labs. We hope to reveal mutually beneficial knowledge exchange on local housing needs and automation opportunities in connection with the projects such as Can Fab. We have worked to nurture participations skill development, both in photography and ethnographic documentation, and help us capture local narratives from participants and residents within Knoll West and those and the women's networks to complement and begin to strengthen existing policy-focused impact strategies that we've been working on. Excuse me. All of the studios are really small interventions as part of a scheme in Bristol to activate micro and backyard sites. In Knoll West alone, there's over 400 sites that have been identified. Knoll West is quite a small community. It's also a very low-rise community, and part of the wider approach to the climate crisis by the mayor of Bristol, Martin Rees, is to densify low-rise areas and low-density areas of Bristol over the next 10 years, primarily because Bristol is on an estuary and there's a huge flood risk most places outside of the city where you would normally see this kind of housing expansion. So actually densifying in the inner city is really important. And these constructions and studios are workspaces for the local community, co-designed and co-produced by the local community, particularly the women that we're working with. So it was through our workshops that we began to have dialogues around the democratization of housing and alternative visions of automation. And we unexpectedly gained really nuanced insight into the personal narratives of our participants' lives. Tony, for example, is a young single parent with an aptitude for photography. Hannah is a mom of two who is now leading production and site teams as part of Can Fab and with AUAR. And she had never previously felt able to hold down a job, but fully immersed herself in Block West prefabrication and construction, now has continued to be employed by us. And Steph saw the entry point of these projects, as an entry point into work after 6 years off as the primary caregiver for her child. And those three women in particular have expressed an interest to continue their participation with AUAR and really begin to think about how they are doing, how they're building an agenda of engaged scholarship. So the block studios use a small enough number of block type A to fit in the back of a Luton van. This makes them very easy to transport from their production places nearby to their sites. And this allows us to really rethink what a factory might look like when it's embedded within a community. For example, for us, one factory equals one robot or a space that can be, you can assemble one block. We realized the need to be really flexible in our delivery to accommodate other responsibilities. So with the participants in the block studios, we agree a structure for the work that works for all participants as part of our consensus building model. And the pilot's really guided by this kind of overarching ambition to understand lived experience of the participants and really begin to expand, think about how expanded ideas of home could offer these microsites, but also how it could begin to scale up to larger sites, which is something that we're working on in AUAR more explicitly. Now, what this begins to unravel for us is to the notion of who is the expert and who is the professional. Again, helping us create a more horizontal framework for wider participation in design automation, with the value that is created really staying within the community itself. And also what that enables is us to think about how we can invest in social and technological infrastructure in communities to really ensure that they have the skills and the knowledge and the resources that they need to adapt and recognize and celebrate their interdependence and grow resilience, not just in terms of material resilience, but in terms of community resilience in the face of all of these really intensely difficult questions around housing and community. And for that, I'll just end there. Thanks so much for having me. I'm really looking forward to some questions.
Thank you very much, Molly. That was fantastic. Really quite amazing. For those of you who don't know me, I'm the director of undergraduate programs here at USC. And I'm going to start off by talking to Molly about some questions for clarification and some things that are burning on my mind. In the meantime, if you can, please insert your questions either into the chat or into the Q&A, and we can go from there. I'm fascinated by your work, Molly. I really love how you think about the automation, about robotic arms and Arduinos and all these things as means to reduce the gap, right? The democratization of different areas, and in a place where it's typically the absolute opposite, what you said before too. The fact that this automation has actually been, dividing our world in classes even more than ever before. So that's just amazing. And the fact that it has to do with community and pulling community together even further, and thinking of it even as terms of economics. It's just purely fascinating. I guess I'd like to start off with a question of just clarification, just maybe because I missed it, I don't know. I understood that the robots can be used in the assembly of the components or the parts that you project. I mean, that I think is a little obvious. The area that I am curious about is the assembly of the structures themselves. And maybe it's because you show a lot of animations and there's nobody putting it together and they just kind of appear. So I guess my question, just for clarification, in that case, is it human, capital that's putting and assembling these structures like the house block, or is there involvement of robot arms in the assembly system or even cranes or other type of machinery to do that?
Yep. So in Block Western and House Block, we did a combination. So we have the prefabrication of the blocks that can be automated, but they can also be done manually. So we had a team of people who were building manually and can also have a lot that are assembled using the automation. But at that stage, we were really, because of the way that the building system is designed, it's very difficult to automate the connections. Extremely difficult. And I didn't show the details of that because we've moved on from it. But as a result, the connections between blocks were done manually as well. And it was actually an incredibly tedious process, yeah. But a fast one. So we could build very quickly. So House Block, which was an 8-meter tall structure, it was basically the size of a terrace house. I guess you don't have, in London, was built in 3 weeks. So, and Block West was built in a week, in 5 days, actually, not even a full week. So it's actually incredibly quick. Now, what we've been doing in the company is automating not just the assembly of the blocks, because actually the assembly of the blocks is highly tedious. It requires a lot of time, and it also requires a lot of precision because of the way that the blocks are then assembled together. You need to have the blocks be exactly the same. So we're now fully automating all of the prefabrication of the blocks, and we've also redesigned the connections so that those can be automated as well. But where we automate them is we only automate them in chunks. So we're not automating the entire construction and then craning it in. We're automating currently chunks of the larger assembly. Is kind of like Tetris in the end when you get on the building site. So you can put things on the back of a truck and you don't need to, get permits to shut down entire streets. You can actually do it in a much more light touch way. So it still remains easy to put on smaller sites, for example.
Well, that makes a lot of sense. And also it opens up the door to different assembly systems of the blocks themselves, meaning different materials and insulations and waterproofing methods that can be part of that block itself. So I can see how it can develop over time to be much more robust and even more diverse than it already is, I guess.
Yeah, exactly. Right now, it's a very typical buildup actually. In the end, particularly in the studio that I showed you the kind of press photos of, but we've developed a modular cladding system. So that cladding system can be either pre-assembled or assembled really easily on site. It's just a slide and click system. So it can be kind of changed more easily. It can also be almost anything that's a sheet that can kind of slide into a frame. It's, we have a kind of diversity in materials that can be used as well. And everything else is really off the shelf. There's nothing that, we need to kind of custom order for any of the studios because it's all materials that you can get at any builder's merchants.
So on that note, have you thought of other kinds of materials that you could possibly incorporate? I know that this is such a time-consuming process, and going through even just the, the wood or the plywood and stuff, you could be on that for years and years.
Yeah.
But I guess speculating on other materials that can be used in there.
Yeah, well, we're moving towards using LVL. Plywood is not a material that we can use for any other scale other than the scale that we're working at. It's really not ideal either for the scale that we're working at. So we're moving towards LVL. We're also using Binderholz, which is an Austrian produced timber. The UK has no, it doesn't have a timber industry. There's beginning to be some in Scotland, but there's really no access to locally made timber unless it's large, sheet timber in particular. So you have to look further afield, and Austria is one of those places that has Binderholz, which is a similar to CLT in its buildup, but it's not quite CLT, and we're using that.
Wow, very interesting. Thinking about and seeing these modular units or the parts that you talk about, and some of the animation that you show that you almost can roll these things right into position, or the robot with the robot arm, it makes me wonder if the design could be projected as actually not needing the robot arm at all in the end by design. So for example, you even talk about the assembly of the parts, right, can be by hand, and maybe you choose to do the robot arm just for uniformity and things like that, but it could possibly be designed to eliminate the robot or motors altogether, so that by weighting it, by changing materiality, it could be completely going back to human-centered type of assembly systems.
No, absolutely. I mean, it absolutely could. I will say though, since COVID, we have, because of the lack of access to things like a workshop, we've really, in the research lab with our students, the emphasis on the work has become around the platforms for production more than the kind of hardware. So that's something that we're hoping, now that we have much more access to the hardware. We finally have within the company, we have a robot cell at ABB headquarters in Milton Keynes now. So we finally have space where we can work that's outside of the university, which still is hugely restrictive. So it gives us more opportunity to touch back on how do we design the piece themselves to become much more versatile in terms of how it's assembled. But that is something that COVID really took a hit on for us.
And then I think I could see it definitely happening, and exactly what you're saying, by not having access to build the prototypes and actually work in that level, it's hard to come up with those solutions. But the other area too is this assembly process itself, or the sequencing of assembly. And so in the end, you show again how that house block came together in animation. Of course, they miraculously just stack on top of each other, and we see it so quickly. But I assume that you have to think very carefully about how this thing is sequenced, because structurally, how do you get around not using scaffolding or something to hold it up, like even a person, sitting there until the joints are actually made. So sequencing, and maybe you can.
So the challenge was to use as little scaffolding as possible. We had one mobile tower, mainly because we're not scaffolders, and we didn't want to be dealing with complex scaffolding. And we also didn't want to have the site be completely inaccessible. So the primary thing that we used as scaffolding was the blocks themselves. So oftentimes what you're not seeing in that animation is how the other blocks are moving around to support the build of one area of house block. So and that's kind of what's interesting about that is that it gives us opportunity to think about, if we were using modular robots that were the same size of the block, how they would then behave too. And where is the builder needed in relationship to that? And how can we design for that choreography to happen in a safe way? And that is a huge challenge. In the end, I was dangling 8 meters in the air in the wind and rain, because I was the one ultimately that I was willing to take that risk rather than somebody that works with me. So you aren't seeing some of the things that probably push the boundaries of comfort for our health and safety officers than I would be willing to admit. But yeah, it does mean we do kind of accept the challenge that like actually this building system could become scaffolding itself. And one of the things that's really interesting is that we're getting a lot of attention from scaffolding companies around some of these ideas that are interested in supporting our development of the building system because they see it as a threat to their core business.
Oh, interesting. That's actually very interesting. So I want to switch over a little gears here and ask some questions about this idea of program material, right? And just looking at some of the design of even the parts, the pieces of that, you mean the unit part that you develop, you mean have a program design of how it actually is assembles together, as well as that part itself and how they assemble the different parts together. And by spending a lot of time designing something that has, on one hand, you can talk about diversity and can do a huge variety of things, including spanning and vertical loads and all this kinds of stuff. Also, potentially becomes overscaled and oversized to do too many things too. Right. So the width that you need to span, for a beam is much deeper than what might be for a column or used for a wall. And so this uniformity then questions things about material or waste or over waste, right? Versus the opposite argument of specificity, right? If we're completely specific for different parts, some people might argue that's a real economy of means and materiality. So I guess my question to you is, have you thought about things like that? And this divided area of economy of means and parts and materials?
Yeah, I mean, there is a lot of redundancy in the building system. And one of the reasons of that is because we do want it to be able to do everything or as much as it can. So yes, that is true. A beam therefore is what we call a beam, or what appears as a beam, is potentially much deeper than what it needs to be, or potentially not as deep as what it needs to be. And therefore we just add more blocks. So we accumulate and we accumulate a sense of redundancy. But what we achieve in other parts of the production process, we see that economy of means balancing out because we're seeing way less material waste overall. We're seeing that we can get huge spans with very little need for specialist equipment. We can do the biggest span that we've tested is 7 meters.
Wow.
So we can get huge cantilevers. We can get things that you otherwise wouldn't be able to get for a much more affordable and accessible amount of money than using other kinds of building systems. So for us, we have to look not just at the kind of problem that we're solving, as a tectonic problem, but also at the wider scale. So we're constantly kind of looking at that as a feedback loop between how we design the block and how we then think about the wider questions.
Right. Yeah, no, it's interesting. I would like to ask the audience to put questions either in the Q&A or in the chat. I'm going to ask a couple more questions and give them a little more time in the meantime. So clearly, and very interestingly, you propose this assembly method and use and application so that it is available to a lot of people of diverse backgrounds or abilities and skills, right? But I'd like to talk a little bit about the design process, right? The process that you're within and the world of developing it, just because we have a lot of students here, looking at it from that perspective. And so how, what is your either advice or experiences on being a woman in this kind of industry? And how can we find a way to increase the number of women, minorities, different backgrounds into the design process of thinking like this, of thinking like you, and the use of robotics and combining that with community and things like that. So I don't know if you have some suggestions to the students on that.
I mean, I think you're highlighting a really big problem within automation and architectural design, period. It's, I can name the number of women working in this area on one hand, maybe two hands, and in the intersection of design, tech and community, it's even fewer. So, I mean, my advice is to find your kin. Yeah, and it took me a long time to find my kin. And the first person that I really clicked with as a collaborator wasn't an architect. She's a social scientist with a doctorate in psychology. And we ended up realizing that we were both really interested in how we could use technology as a way to activate a wider participation of people with that technology. So, you know, she was working really specifically on the psychology around that. I was thinking about how do we challenge pre-existing conceptions of what technology is within architectural production. And that's where that kinship began to be formed. And then that kind of had a domino effect. So I think, you know, it's kind of finding those kins, and those kins might be people that are working around you, but those kins might also be our ancestors. It might be people that are writing around those topics. And I think for me, you know, I really try to build that sense of kinship and community, not just in my academic life, but also in my professional life around how we work within communities. So we spend a lot of time working on the ground. So a lot of the work that we're doing, where you're seeing the fancy image of Block West, but you're not seeing the year prior of work of going door to door and talking to people. You're not seeing the 20 years of work that Knoll West Media Center had in that community beforehand that enabled us to go door to door and not be shut in our face. And all of that work is something that you have to really appreciate and celebrate within the project itself. So that's one of the things that for me, I think is really promising, is that when we have students who are willing and able and understanding of how difficult that work is, and to design that into their projects rather than having it be an after effect. So one of the things that I think is really problematic is that oftentimes we look at design briefs as like we're solving problems. Architects view themselves as, let's say, problem solvers, but we're not really problem solvers. That's one small bit of what we're doing. I think we actually have a more important role to play, which is kind of activating and enabling and facilitating. And that takes a different kind of lens. That takes a question of like, okay, what's here? What's here? How can we, oh my God, that's what's here. This is an amazing thing. How do we support that coming to the surface more? So I think that for me is and that's supported again through this idea of kinship. How can we gain that trust with people to begin to show what's possible?
Wow, fantastic. So we do have a question here that I'm going to launch into from Brandon Jacobson. I'm going to just read it just so for everyone to hear. Thanks for the presentation. I am curious if you think this kind of prefabricated automated construction will stifle design creativity and reduce the need for even architects when artificial intelligence can use the prefabricated parts and put them together like Legos. In the future, could it be where there is little to no human input, thus reducing the need for human labor?
So this is a question I get probably every time I talk to anyone. No, I don't think that there will be any place where any time where there will be no or very little human labor. I think actually that's a really important part of this is understanding where human labor plays a role and where it's necessary. So a lot of the work that a lot of my work, and I didn't present this today, is really based within post-work imaginary, where we think about how can automation enable us to work less, and how can society be constructed and designed to so that our basic needs are taken care of, and so that we can have more time for creativity. So a lot of the way that I'm thinking about automation and way that I'm thinking about working in communities has that as its backbone. Like, what if we didn't have to work? What would we do then? And what are the things that we should build into the way that we're developing these tools and technologies now, so that we can really allow for that space to be explored and for that creativity to flourish. So I don't think that there ever should be a world where we don't have any human input. I think actually it's the backbone of being human, is actually this notion of creativity. So yeah, I don't think it will reduce the need for architects or laborers or tradespeople. I think it's only going to create new ways of working and living that will be even better.
Yeah. And just to add to that too, I guess even thinking further down in the future, as people are looking at the moon or Mars or, outer space type of lifestyle, this idea of automation, is probably more aligned with that kind of assembly system, or not automation, but again, I look at it a little more as pre-programmed, materials that you're designing that can be put together. So it's an interesting idea. Okay, so we have another question. I'm sorry, I'm going to pronounce the name very poorly. Farah Al-Khalaf, sorry. Really enjoyed your presentation. Just like 3D modeling softwares, tech adds to design possibilities, but can also limit. What do you think are the design limitations that can come with robotics?
So there's things that robots are really good at, and then there's things that robots are not really good at. And one of the things that I highlight is that robots are really good at repetitive behavior. That's when you're really making the most out of your robot, when you're getting it to do the same thing over and over and over and over and over again. Because oftentimes the thing that it's doing over and over and over and over again are things that if you were doing them as a person, you would hate that job. So in block type A, in its very first iteration, we had like loads of T-nuts that needed to be banged in before you even assembled it. Horrible job. Really hurt your wrist, no matter how good your form was, like it was loud, horrible, absolutely horrendous. But if you could automate that, you would really enjoy your job a lot more. So again, it's like, and that's a design question, right? It's like, why do you need a T-nut? In our case, it was so that you could connect blocks back to back. And so that you could connect through 3 blocks. So as soon as you begin to limit that T-nuts placement or how many T-nuts that you use, you're beginning to also think about how it limits those design possibilities. Now, if you can have that automated, then you can actually keep those design possibilities. So it's really thinking about like that relationship at all times. What is the benefit of using the automation, and at what point does it become pointless to use it because you'd be doing so much customization that it wouldn't be worth your time or take too long, et cetera. So that's just one example. And that's embedded, that question is embedded in every single part of the things that we do, in all of the connections and every kind of little etch that we make in a block, all the tools that we use, et cetera.
I'm going to ask another question about the robot arm itself. So we presume you mean the industrial robot arm as part of the process. But do you ever think about the redesigning of the robot itself, right? So that yeah. So maybe you can talk more about that.
Yeah. So I mean, I think I showed a video of one of the modular pizza bots. They were the pizza box robots. So the robot arm for us is really just prototyping behavior that could then be embedded within a modular robot and therefore be distributed. So none of the behavior that the industrial arm is doing is something that can't be done if we were to modularize it and have a distributed robot. So again, there's this kind of design feedback loop in the way that we're using the arm versus the way that we're thinking about a more speculative version of the robot. And where we've done that is really thinking about, like, is there a robot that could be a building element? Or do we have this kind of active passive relationship of building element and modular robot? And where, to what degree is that possible? Can those robots build themselves? Or do we need another kind of robot to do that? So that's definitely part of what we're working on. It's primarily the work that we're doing in the lab with the students rather than the company. The company is much more focused on the delivery of homes. So it's, we are some ways off of being able to really think about how we can have modular distributed robots really working in the kinds of settings that are part of the student work.
But I imagine that could happen too, especially if you think of the robotics as being part of the fastener systems too, right? So rather than the parts themselves, that there's a way that the fasteners can help build it and then also be fixing the thing in place in the end. Yeah,
absolutely. I had a visiting professorship at ICD in the autumn, And one of the student projects coming out of iTech is a project that was really thinking about those fasteners. So how to use the arm to fasten in a kind of on-site fabrication setting. And it's I think brilliant work, but again, it's constrained by a lot of things like how big is the robot, and how big is your site, and where are you doing it, and is it really in a factory or is it truly on site, and things like that. But it's absolutely a possibility. I think this is where things like computer vision and machine vision really can come into play, because they can allow us to embed some kind of autonomy into the arm. That doesn't need necessarily a human eye to say that it's getting the precision that it needs.
Yeah, no, I can definitely see how that would happen, or how the fasteners themselves could have robots built within them, right? So they're more cobotic or collaborative type of robots that you're referring to. Okay, so I will ask one last question, I think, just because I find it so interesting. In your biography, you talk about yourself being an activist, a doula, and a trade unionist, all in the same sentence.
Yes, very loaded.
And very loaded. And I wonder if you could talk a little more about that, because in some ways, I think each of those words individually can be reinterpreted, you know what I mean, in different ways too. And maybe they have relationship to each other or not at all. So,
well, I think, so I've generally speaking have been involved in some form of activism or another for about 20 years. I was one of those kids that their parents took them along to a lot of different kinds of protests. And since I've been in the UK, I was very deeply involved with the Extinction Rebellion in 2019 and 2020, or 2018, 2019, 2020, up until quite recently. So that work was really around world building. So what are the kinds of alternative worlds that we want to create? And one of the bits of work that I was doing was around decision-making structures. So how do we embed those decision-making structures in some of the actions that we were doing? So it was very much ingrained in the built environment and the places that we were doing actions. So oftentimes that was producing actions that directly interacted with the local community. So again, it was kind of building on some of the strategies that I use in my academic work and professional work, and also just kind of interplaying, and it became a kind of testing ground for some of them, particularly around consensus based decision-making, which Extinction Rebellion uses extensively. And then my doula work is, I work for an organization called Doulas Without Borders, which provides free doula care to refugees, asylum seekers, people who have suffered from sexual violence, domestic violence, young parents. And oftentimes that's work that takes place in the home. It's very much a domestic work. And I work as an interface between people who are in very vulnerable positions in their homes and the wider system. So the NHS system in maternity care is highly underfunded and understaffed. And so I'm constantly acting as a kind of mediary for people who are in very vulnerable positions to access the kind of care that they need. So again, a lot of the things that I work on in my work is embedded in my approach to my doula work. And then for the last 3 years, I've been the union rep for the School of Architecture, which is our union is University Colleges Union. It's the biggest union in the UK. And we've gone on strike like 4 or 5 times over the last few years around things like workload, pensions, gender equity, racial equity. So as you can imagine, have been like in the position of advocate in that role as well, using a lot of the work that I'm doing. And some of that work has bled into some of the strategies that we've used in the Bartlett to address issues that have been highlighted by the recent investigation around bullying and harassment that's taken place over the last 20 years. And so some of the strategies that are now being deployed in the School of Architecture have come out of a lot of the work that we've done in the union around how do you embed conversations and in really safe ways amongst a large group of people that are oftentimes sitting in positions of conflict with one another.
That's fantastic. I mean, given the fact that we've gone through this pandemic recently, and you're in a business where in all these things are very active, you seem to have been very productive regardless, and a lot of fantastic things.
Thank you.
And thank you very much, Mollie, for sharing your work with us. It was fantastic. It was enlightening. It was inspiring. Again, Mollie is in London right now, and so it's very, very late in the night. We'll let you
Very late.
go back to sleep.
Yes.
But again, thank you on behalf of our school, our dean, our administration, faculty, and students. And hopefully we'll see you in person in the near future. Good luck with everything. We will
Thanks
be
so much.
following your work.
Thanks so much.
Thank
Appreciate
you.
it. Have a good night.
Yeah, you